Alright, today I'd like to talk a little bit more about the development of the atomic theory. How do we get some of these atomic models? Now we're beyond the Greek guys, we're beyond the older guys. We're going to talk about Crooks and J.J. Thomson if we have enough time. So, continuing on here. There we go. Okay, so Crooks was the first guy to come around, and he came up with what's called the Crooks tube. Okay, a Crooks tube is basically just a tube that has a vacuum in it, and we're running electricity through there. A whole bunch of electricity is just coming through. Now, once this wire is here, you can see that it made like this green fluorescence, and you'll see that in just a little bit in a video, assuming it comes in on a jing pretty good. There's this green fluorescence. Now, the question is, what is that green fluorescence? That's what we're taking a look at. So we got a Crooks tube. Some of you might have a Crooks tube at home if you have an old cathode ray tube TV. You know, the TVs are like 3 feet thick and stuff like that. That is an old cathode ray tube. Now, Crooks did a few different experiments on it. The first experiment that he did was he put a shape in it. Now, the shape happens to be a Maltese cross, but he put a shape in it, and you can see, let me see if I can pause it. Oop, little bit too late. Alright, right here you can see that it's got it makes a shadow with a very defined edge. There's the shape right there, and it's making a shadow with a really, really clear cut edge. Now that taught him something very important about this. That told him that was a particle and it was not a wave. That whatever this green fluorescence is, it's a particle and it's not a wave. Well, let's explore that. Why does that mean that it's a particle? Well, I'm going to give you an analogy here. Pretend you go to the beach, and here's the beach right here. There's the beach. There's an umbrella. You're looking down from above, okay? And you're out there, and there's a really, really big guy. He's 500 pounds. There's his head, his belly button right there, and you got waves coming in. Well, the waves are obviously going to come and hit him. Now, the question is, will the waves just make a hole all the way back in to the beach, or will they start coming around him, start coming together, and so it's kind of a whole wave when it comes back into the beach? And the answer, of course, is that the waves, they're going to diffract, they're going to come around him after hitting him. They're going to bend. Now, if this green fluorescence was a wave coming through here, it would bend around the shape and it would give the shape a fuzzy edge. But since it had a clear edge, he used that as evidence to say, oh, it has to be a particle, cannot be a wave. So what did he do? He proved it was a particle, was not a wave. Now, there's another experiment that he did. He did a paddle wheel, and we'll see how well of a video we can get up from this, but there's kind of showing right here all the different components. It's a little dark, sorry about that, but here you go. It's a little paddle wheel. Now, it was on rails. They're reversing this Crooks tube. They're shooting the fluorescence one way, then they're shooting it the other way, and the paddle wheel moved. It started rolling around in there. It started moving in the direction that they were shooting the green fluorescence towards. So that means that whatever this stuff was, that means that it had, oh, got a little far from me, it proved that it had mass. So the paddle wheel experiment proved that it had mass. Thank you. We will continue with J.J. Thomson next time.